Okay, 23. We've got 3 point masses at on the number line. One's at -6, one's at 1, and one's at 3. And they are all 4 grams each. And we want to find where should the fourth point be so that the center of mass is at the origin. So I want the balance point to be here at the origin. So what is that going to look like? Well, I know this is 6 units this way because they're all the same mass. That's 1 unit that way and 3 units total for that guy. So there's 4 units of weight to the right and 6 units to the left. So I know somehow the other mass has to be to the right of 0. That's just me looking at it, kind of thinking ahead. So let's just say it's out here somewhere. I don't know where it's at. We'll call it X. Well, that means all of the moments, 4 times -6, which is the mass times the location, have to add up to the center of mass, right? Which is X bar, which is 0, because we want it to be 0. So then we'll have -24 plus 4 plus 4x plus 12 equals 0. So is that 4x equals, if I can do this in my head, 8. So x must be 2. So when x is 2, when this mass is put at 2, the moments on this side equals the moments on that side, or the weights of this equal the weights of that, which make it balance at 0. Okay, alright, there we go on that. Let's look at 25. Now I've got a rod with density given by that formula. So here's a rod, it's pi units long, and the density is given by 2 plus sine of x, where x is my distance from the origin. So at any x, the density at that point is given by 2 plus sine of x. Okay, so to find the center of mass, as we developed in class, is the integral from 0 to pi of x times delta x dx divided by 0 to pi delta x dx. These are the sum of the moments of all the slices over the sum of the masses, all the slices of masses, and then we integrated to sum them up as the thickness goes to 0. So if we go ahead and do this, x times 2 plus sine of x over 0 to pi of 2 plus sine of x dx. Then I get some nice integrals to do here. So I'm going to have the integral from 0 to pi of 2x plus x sine of x dx over the integral of 0 to pi of 2 plus sine of x dx. Now this one, I look at the denominator, it's like, yeah, I can do that. The numerator, I can do that easy enough. This looks, oh, that's one of those ones that's not obvious. It's an integration by parts. So let's go ahead and do these. So this becomes an integral from 0 to pi of 2x dx plus the integral from 0 to pi of x sine of x dx over the integral from 0 to pi of 2 plus sine of x dx. Alright, so let's just do each one of them individually. So this is 2x squared over 2 from 0 to pi plus, I'm going to leave that blank because we're going to do that on the side. And the denominator becomes 2x, plus, let's see, derivative sine, integral of sine is negative cosine, because the derivative of cosine is negative sine from 0 to pi. Now remember, I'm going to fill this in here with that integral in a minute here. So this one becomes pi squared plus whatever that is over this becomes 2 pi minus the cosine of pi. Cosine of pi is negative 1 minus 2 times 0 minus cosine of 0. Okay, so the denominator becomes 2 pi plus 1 minus cosine of 0 is 1, so it'd be plus 1. Okay, so we've got 2 pi plus 2. So we're going to get pi squared plus whatever goes there over 2 pi plus 2. Okay, now I got to figure out what is in that box. Okay, I've got to do this. I want to do this just as a good reminder. So we go, oops. So I'm going to do it by parts. I'm going to let u equal x, dv equals sine of x dx. So du equals dx, and v equals negative cosine of x. Alright, so then this becomes uv, negative x cosine of x from 0 to pi minus the integral from 0 to pi of v du. Negative cosine of x dx, so negative cosine of x dx, which becomes, so this becomes negative pi cosine pi minus 0. Integral of cosine is negative sine, or no, sine, right? The derivative sine is cosine. And so this becomes, cosine of pi is negative 1. So that'd be pi plus sine of pi minus sine of 0, which is, both of those are 0, so it becomes pi. So this is pi, pi, pi. So back down here to my answer, if I factor out a pi on the top, I get pi plus 1. If I factor out a 2 on the bottom, I get pi plus 1. So those cancel, so I end up with pi over 2. Wow, that's a lot of work for this problem. And that gives me the center of mass for this rod. It kind of makes sense that it would be in the middle because this is periodic and pi is what, half a period of pi, or a lot of symmetry and things like that. Alright, there you go.